So in this video, we're going to solve an equation that has a rational exponent in the case where the numerator of the rational exponent is even. So just like in the previous example, we see that we have an equation for which there is a ratio exponent. So the first thing we're going to do is isolate the algebraic expression that's being raised to that exponent. So if I rewrite the equation, I get negative 3 times x minus 2, my algebraic expression that's being raised to the 4/5 power, plus 29 equals negative 19. And we want to isolate this expression right here. So I'm going to start by subtracting 29 from both sides, which is going to give us, what, negative 48, negative 19 minus 29. Should be negative 48. And then that's going to leave us with negative 3 times x minus 2 to the 4/5 power. We don't quite have our expression isolated yet. We're going to divide by this negative 3 on both sides. Negative 3 divided by negative 3 is 1. 1 expression being raised to the 4/5 power. And we have a negative divided by a negative is a positive, and 3 is going to go into 4 once and into 18 6 times. And then once we get our algebraic expression that's being raised to the rational exponent isolated, we want to look at the numerator carefully and say, is it odd or is it even? And because it's an even exponent in the numerator, we know that not only will positive numbers raised to an even exponent give us positive results, but negative numbers raised to an even exponent will give us positive numbers as a result. So this numerator being even tells us that we're going to get both a plus and a minus in our solution. We're going to get a positive and negative number as a solution. And we know that v can't be a negative number because we cannot raise a negative number to an even exponent and get anything other than a positive result. So it's impossible. If we had a negative 16 on here, we would stop and we would say, hey, there's no solution. Fortunately, it's a positive 16, so we know there's going to be a solution, and there's going to be two solutions, a negative number being raised to an even power and a positive number being raised to an even power. So we're going to take and raise both sides to the 5/4 power. We're doing the we're raising it to the reciprocal of 4/5, because 4/5 times 5/4 is 1. We get x minus 2 to the first power, but we don't need to write the first power. Whatever we do on one side, we do to the other. So we raise both sides to the 5/4 power, and we know we're going to get a positive and negative number that work. So we go plus or minus, and then we can start to simplify things a bit here. So this says take the 4th root of 16. This 4 is in the denominator. So it's the 4th root of 16. And the 4th root of 16 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So we get a 2, and the 2 still needs to be raised to the 5th power. That's the numerator. And 2 to the 5th power is going to be plus or minus 2 to the 5th is 32. So we have x minus 2 equaling plus or minus 32. We add 2 to both sides to isolate the x. So we get 2 plus or minus 32. And that's going to give us x equals 2 minus 32 is going to be 2 minus 32 is going to be negative 30, and 2 plus 32 is going to be 34. When you take these numbers and plug them back into the original, look at what happens. You get negative 30 minus 2 is negative 32, and the negative 32 raised to the 4th power is going to be a positive number. And if you plug 34 in, you get 34 minus 2 is going to be 32. Positive 32 raised to the 4th power, positive 32 raised to the 4th power is going to be the exact same number as negative 32 raised to the 4th power, because the 4th power will cancel that negative. So really, to check whether our solutions work, we only need to plug one of the two in, and as long as one of the two works, both of them are going to work. So I'm going to go ahead and plug the 34 in just as a check on my work. So I plug it in, I go negative 3 times 34 minus 2 raised to the 4/5 plus 29 equals negative 19. And then we subtract this 29 from both sides, which is going to give us, 1848, negative 48? No, we don't need to do that. Good heavens. We'll just simplify the left-hand side and see if we get a negative 19. So 34 minus 2 is just 32 to the 4/5. And again, the reason I'm only going to check the 34 is when we plug negative 30 in here and we get negative 32 instead of positive 32, but raising to the 4th power just kills the negation on it. So as long as 32 to the 4th works, negative 32 to the 4th is going to work as well. And this is plus a 29 right here, so equals negative 19. So this 5 is in the denominator, so this is saying take the 5th root of 32. It's saying take the 5th root of 32. What number times itself 5 times is 32? And the answer is 2. And you could check it if you don't believe. 2 times 2 is 4, times 2 times 2 is 4, times the extra 2, we get 16 times 2 is 32. So we can simplify that. The 5th root of 32 is just 2, but we'll still need to raise it to the 4th power and add the 29. So we get equals negative 19. 2 to the 4th power is 16. So we get negative 3 times 16 plus a 29. And negative 3 times 16 is negative 48 plus the 29. And negative 48, 30 would be negative 18 with the 1 extra gives us negative 19 equals negative 19. We get an identity. So we know that 34 was a solution, and because of the reason I explained before, negative 30 is also going to be a solution in this case. So the solution set is X is an element of the set that contains both negative 30 and 34. It's supposed to be a curly brace. There we go, that's better.